Welcome back, everyone. Now, if you are currently studying for your Cambridge Mathematics exams, you already know the golden rule. Every single mark counts. You literally cannot afford to leave anything on the table. So today, we are building your ultimate foolproof cheat sheet for cracking one of the most consistently tested yet surprisingly tricky topics on the entire syllabus. We're talking about ordering questions. I know. You're probably thinking, ordering numbers? Really? Didn't we learn how to do that back in primary school? But listen, Cambridge examiners have a very specific, very clever way of testing this topic just to see if you are really paying attention to the details. My goal for you in this explainer is to hand you a highly structured, step-by-step strategy so you never, ever drop a single mark on these questions again. Let's get right into it. Look at the question we have right here. Which is bigger, 3/8, 0.45, or 35%? This right here is the classic examiner trap. They absolutely love to put numbers into what I like to call different disguises. They'll take a perfectly simple list and completely mix up fractions, decimals, and percentages in the exact same question, just to mess with your head and trick your eye. Your brain naturally tries to quickly compare an 8, a 45, and a 35, and suddenly, you're second-guessing yourself, you're freezing up. But honestly, don't worry. By the time we finish this explainer, unmasking these mathematical disguises is going to be total second nature to you. Okay, let's dive into our 5-step systematic roadmap for totally mastering this topic. First up, we'll look at the number disguises. Second, we're tackling integers and metric units. Third, we introduce a massive game changer, the decimal equalizer. Fourth, we'll go over specific tactics for fractions. And finally, we will face the ultimate mixture. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's keep moving. Section 1, the number disguises. Look, before we can even think about comparing and ordering complex lists of numbers, we need to make absolutely sure we deeply understand the basic mathematical language of comparison. We have to walk before we can run. It all starts with the foundational inequality symbols. You've seen them a million times. The arrow pointing to the left means less than, and the arrow pointing to the right means greater than. And of course, when there's a solid line underneath the arrow, it adds or equal to into the mix. I totally get that this seems super basic, but let me tell you, under the intense pressure of an exam hall with the clock ticking down, it is incredibly common for even top students to flip these around in their heads. You need to lock these into your memory right now. A fantastic mental trick to always fall back on is to remember that the wide open part of the symbol always faces the bigger number. Just imagine it's a hungry mouth eating the larger value. Moving right along to Section 2, integers and metric units. This is where we step up into our first real level of exam complexity. We're dealing with whole numbers, but they have completely mismatched metric units. This is a classic move where the examiners test if you remember your basic conversions before they even let you start the actual ordering process. So how do we handle this? Here is your bulletproof 3-step rule for handling metric units. Step 1. You need to write every single value using the exact same unit. And the absolute pro tip here, straight from the textbook, is to always use the smallest unit available to you. Why? Because it usually saves you from having to deal with messy, complicated decimals. Step 2, simply order those newly converted values. And step 3, please pay close attention to this one, because this is where so many students lose easy marks. You must write your final answer using the original units given in the actual question. So just to be crystal clear, you do the math using your converted units, but you write the final official answer using the original disguises. Example 5.1 from the source text brilliantly illustrates exactly how this works in practice. We have a total mix of kilograms and grams: 1.2 kilograms, 1,500 grams, 175 grams, 2 kilograms, and 0.8 kilograms. Now, if you just try to order these in your head by looking at the raw numbers, it's a complete mess. The 175 looks huge compared to the 2, right? But by converting everything to grams, which is our smallest unit here, we get 1,200, 1,500, 175, 2,000, and 800. Suddenly, putting these in order from smallest to largest is the easiest thing in the world. 175, then 800, then 1,200, and so on. But remember step 3. Your final answer line on the exam paper must read 175 gram, 0.8 kilogram, 1.2 kilogram, 1,500 gram, 2 kilogram. You've got to give it back to them the way they gave it to you. Section 3. The decimal equalizer. All right, We are moving away from whole numbers now and looking strictly at decimals. Decimals are incredibly tricky because our human brains naturally want to think that a physically longer number is automatically a bigger number. But with decimals, different lengths after the decimal point are literally just an optical illusion designed to trick your eye and ruin your confidence. To completely beat this illusion, we're going to use what the textbook describes as a zero padding exam hack. It's genius. Here are the steps. First, you just add zeros to the end of your shorter decimals so that every single number on your list has the exact same amount of digits after the decimal point. Second, temporarily ignore the decimal points entirely and ignore any zeros at the very front of the number. Third, order those new, super easy-to-read numbers by size. And finally, just like we did with the metric units, revert them back to their original formatting for your final answer line. Let's look at this straight from the source material, example 5.2. We are asked to order 0.412, 0.0059, 0.325, 0.046, and 0.012. Okay, the longest decimal here is 0.0059, and it has 4 decimal places. So we're going to pad all the other numbers with zeros until they also have exactly 4 places. So 0.412 becomes 4120, 0.046 becomes 0.0460. Once they are all the exact same length, if you temporarily drop that decimal point, you are simply comparing the whole numbers 4120, 59, 3250, 460, and 120. It completely eliminates all the confusion. It makes the comparison absolutely foolproof. Now, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back into it. Section 4. Tactics for fractions. Now, fractions require a little bit more strategic decision-making on your part, and your strategy here is going to depend entirely on one single factor: whether or not you are actually allowed to use a calculator for that specific exam paper. The textbook actually outlines 2 totally distinct tactics for this. Method A is finding a common denominator. Let me tell you, this is your absolute best friend on a non-calculator paper. Once the bottom numbers of the fractions are exactly the same, you just look at the top numbers and order them by size. Easy. Method B is converting every fraction into a decimal using division. Now, this is usually way faster if you have a calculator handy, but it can turn into an absolute nightmare of manual long division if you don't. So pick your battles wisely. Let's see this in action. In example 5.3, the question asks which is bigger, 3/4 or 5/6. Using method A, we know we need a common denominator. Now, the text smartly points out that while you can always just multiply the denominators together, like 4 times 6 is 24, finding the lowest common denominator makes the math so much easier on yourself. Here, the lowest common multiple for 4 and 6 is 12, so 3/4 becomes 9/12, and 5/6 becomes 10/12. When you look at it like that, it's immediately obvious that 10/12 is bigger. Finding that lowest common denominator keeps your numbers small, friendly, and totally manageable. Section 5, the ultimate mixture. Okay, this is it. This is the boss battle of the ordering topic. This is where the examiners basically throw everything, including the kitchen sink at you, in a single question. A chaotic, messy mixture of fractions, decimals, and percentages all living together in one single list. Example 5.5 perfectly demonstrates the ultimate rule for handling these mixed formats. And the textbook is very, very clear on this point. The absolute easiest, most reliable way to compare a mixture of fractions, decimals, and percentages is to change every single one of them into a decimal. Do not try to make them all fractions. Don't try to make them all percentages. The decimal format is the grand equalizer. It puts everything on the exact same playing field. Let's visually prove just how incredibly well this works. Taking our totally chaotic original list from example 5.5, we've got 1/4, 3%, 0.41, 11/40, and 0.35. At first glance, it looks incredibly confusing, right? But watch what happens when we use the decimal equalizer. 1/4 becomes 0.25. 3% is 0.03. 11/40 becomes 0.275. Suddenly, we just have a super neat, clean list of decimals. From here, you just use the zero padding trick we learned back in section 3, you order them by size, and then you write them back out in their original format for your final answer. Honestly, it works like magic every single time. But before we go any further and wrap this up, I need to stop and highlight this highly specific warning box straight from page 30 of the textbook. Quote, a common error is to write 3% as 0.3 rather than 0.03. I want you to read that again. I am putting a massive emphasis on this because examiners see this specific mistake thousands of times every single year. Let's think about it. 3% literally means 3 out of 100. That is 0.03. 0.3 is 30%. It's a huge difference. Please do not let a simple, totally avoidable decimal shift rob you of your hard-earned marks. All right, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Now let's bring it all together. Here's your rapid-fire mental checklist straight from the textbook's key points. Memorize this before you walk into the exam room. 1. Know your inequality symbols perfectly. 2. If you see mixed metric units, immediately convert them all to the smallest unit. 3. When dealing with decimals, add zeros to the end to equalize their length so your eyes don't get tricked. 4. The ultimate hack for mixed formats is converting everything to decimals. And 5. The single most important rule of all, always write your final answer using the original numbers the exam gave you. By strictly applying these structured, visual rules, you take a problem that initially looks confusing and messy, and you completely turn it around into a step-by-step process that guarantees you full marks. Are you ready to unmask any disguised number they throw at you on exam day? Once you completely master ordering, what other mathematical illusions are you ready to expose? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing, apply the framework, and I'll see you in the next explainer.